All right, we are here at lesson 3.2, theorems about perpendicular lines. I always get excited when we see the word theorems because that's going to be where we explain our logic. So we're going to use theorems, we're going to use the facts we know about perpendicular lines, primarily to find angle measures and relationships. So let's take a look at what that looks like. All right, theorem 3.1. All right angles are congruent. All right, that's what we're doing there. You might look at that and go, duh, Miss Woodard, I know that, but that can be one of our theorems. That's going to be part of the logic that we explain, is that we know all right angles are congruent. So symbolically, if the measure of angle A is 90 degrees, and the measure of angle B is 90 degrees, so we know that because they put our symbols in there, then angle A is congruent, use our congruent symbol, to angle B. We'll delete that. Sorry, guys. All right. Let's take a look at theorem 3.2. If two lines are perpendicular, then they intersect to form four right angles. And some of you have already kind of figured that out when we were looking at things in chapter 2. But if n is perpendicular to m, there's that symbol for perpendicular that we talked about in 3.1. So if n is perpendicular to m, then angle 1 is 90 degrees. But using what we know about linear pairs, then angle 2 would also have to be 90 degrees because these two make a straight line. And then we know that angle 3 would have to be 90 degrees because angle 2 and angle 3 have to make a linear pair. And then we know angle 4 would also be 90 degrees. All right. So follow up. How do you know each statement is true? If two lines intersect to form a right angle, then they are perpendicular lines. That is our definition of perpendicular. All right. And how do we know if two lines are perpendicular, then they form four right angles? Well, that was theorem 3.2. Now what happens here, guys, is they're giving you theorem numbers, and those theorem numbers are truly only specific to this textbook. And so instead of using the phrase theorem 3.2 and trying to memorize all those numbers, what I'm going to have you do is use the logic behind that. I'm going to have you tell me that two lines are perpendicular, then they form four right angles. So let's take a look at what that looks like. So perpendicular lines in our reasoning is example 1. We know line R is perpendicular to line S. We see the 90-degree angle mark here. And we know line R is perpendicular to line T. We see the 90-degree angle mark in there. So we understand that they're perpendicular. And then decide whether enough information is given to conclude that the statement is true. Explain your reasoning. So for A, we want to look at this and decide, is angle 1 congruent to angle 5? Is angle 1 congruent to angle 5? And enough information is given. And how do I know? Well, because all right angles are congruent. They're all stuck together. Because all right angles are congruent. And that's part of what we see here in theorem 3.1. But instead of stating 3.1, I just tell you, well, why do I know that? Because all right angles are congruent. So angle 4 is congruent to angle 5. Well, enough information is given for that one. Because when two lines intersect in a 90-degree angle, when two lines are perpendicular, it creates four right angles. So that means angle 4 is also congruent to angle 5. because the measure of angle 4 equals 90 degrees. No, I guess I don't want to say because. You start off with angle 4 equals 90 degrees. The measure of angle 4 is equal to 90 degrees because two perpendicular lines create 4 right angles. Now, I should have said this at the beginning of the problem, guys. This isn't filling in the blanks of what you have, so you're probably going to need to put it over there in the margins. They want you to fill in theorem 3.1, theorem 3.2, theorem 3.3. I don't want you to memorize numbers. I want you to understand the logic. Because all right angles are congruent. Because we created 4 90-degree angles. So if we look at this, angle 2 for letter C is congruent to angle 3. Well, all I know is that angle 2 and angle 3 are complements. I don't know anything about their angle measures. If we look at the original diagram, there's no marks here. Nothing is marked in either of these angles to point out them being congruent. So this would simply be enough information is not given. All right, so your checkpoint, ladies and gentlemen. I'm going to go through the first two. We're going to leave 3 and 4, I should say, there to see if we can check those in class. So 3 and 4 are a check in class. So that means you do them now. Okay? I'm going to do 1 and 2 with you. So angle 6 is congruent to angle 10. Well, if we look up here, here's angle 6, here's angle 10. Is that true? Yes. Because all right angles and you guys have noticed I've started abbreviating angles because we're going to be using that word a lot here in this chapter, so we can abbreviate that. When we take a look at number 2, angle 7 is congruent to angle 10. So I'm going to look at angle 10, and I want to know, is it congruent to angle 7? Well, I need to do a little bit of adding here, because if angle 6 is 90 degrees, that means this angle is 90 degrees, which makes this a 90-degree angle, and makes this a 90-degree angle. So our answer here is yes, they are congruent. They are both 90-degree angles. Because perpendicular lines create 4 90-degree angles. Okay, and then we can say 10 and 7 are both 90 degrees. Your job is to look at angle 6 and angle 8. So you're going to look at angle 6 and angle 8. Look and see what you know about those. And then look at angle 7 and look at angle 11. Check those in class. All right, theorem 3.3. If two lines intersect to form adjacent congruent angles, then the lines are perpendicular. We took a lot of look at two lines intersecting in chapter 2, and we almost always had 2 different measures for those adjacent angles. But if these adjacent angles, angle 1 and angle 2 in this picture specifically, are going to be congruent to each other, that means they have to be 90 degrees. That's the only value that when double, when you have 2 of them, equals the 180 that we have here in this straight line. So what this looks like in symbols is that if the measure of angle 1 is congruent to the measure of angle 2, then line AC is perpendicular to line BD. I typed this in here, guys. This is what you're filling in your notes. All right, let's take a look at theorem 3.4. If 2 sides of adjacent acute angles are perpendicular, then the angles are complementary. All right, so if the 2 sides of adjacent acute angles are perpendicular, so when we look at this, we've got this angle, and then we have this angle. So this is their shared side. This is the one they share. These are the two sides that we're looking at. And those two sides make this 90-degree angle. So because those two sides came together to form this 90-degree angle, they're perpendicular. So we know 3 and 4 have to be complements. So if EF is perpendicular to EH, so EF is perpendicular to EH, so here's this EH, we know our symbols here, then the measure of angle 3 plus the measure of angle 4 has to equal 90 degrees. All right, example 2, ladies and gentlemen, I've looked through that and I'm not impressed with it. They don't give you enough information to tell me that they are either perpendicular or that they are equal to each other. So we are going to skip that one. But we are going to go on and take a look at example 3. We're going to use algebra. So in the diagram at the right, we know EF is perpendicular to EH. It helps that they also put the 90-degree angle mark in there. They don't have to do that, ladies and gentlemen. If they're going to give you this information, it's your job to put in that perpendicular mark, to put in that 90-degree angle. And we know that the measure of GEH is 30 degrees. So here's our 30-degree angle. We want to find the measure or the value of Y. So we know that FEG and GEH are adjacent angles so that they are complements. We had two lines making or two rays intersecting at a 90-degree angle, so that meant the two angles inside there were complements. So measure of angle FEG plus the measure of angle GEH equals 90 degrees because FEG and GEH are complements. That's our reasoning. That's our logic. All right, so what we're going to do is substitute in the angle measures. FEG is 6y. GEH is the 30 degrees, and we know that equals 90 because they're complements. We want to subtract 30 from each side, so that means 6y is going to equal, when I subtract 30 from 90, I get 60. And then we have to divide each side by 6. So we get y equals 10, which is exactly what they want us to do. What we're going to do for the follow-up is we want to check our answer. We want to know, does that actually work? So we take a look at this. We know the measure of angle FEG, look at the two angles you have, was equal to 6y degrees. We know that the measure of angle GEH was 30 degrees. So if I plug y in, I've got this equaling to 6 times 10 degrees, which is 60 degrees. If we take a look at what we know that the measure of angle GEH plus the measure of angle FEG is equal to 90 degrees. So 30 plus the 60 that we got when we plugged in 10 does equal 90. So that is a good check of an answer. All right, find the value of the variable and explain. I know that EFG is congruent to HFG. We know that they're congruent. Well, if they're adjacent, these are adjacent angles, all right, then we know that adjacent congruent angles formed by intersecting lines they both equal 90 degrees. So that means 5x is equal to 90 degrees. This looks similar to what you have done before. We would have said 5x plus something has to equal 180. Well, I don't know this 180. But what I do know is once these two angles are congruent to each other from those intersecting lines, that each side has to equal 90 degrees. So I can take 5x is equal to 90, divide by 5, and we get x is equal to 18. This is going to be a check in class. So this means you need to do now. I want you to definitely find x. Okay, guys? And then if you need to name the theorem, look back in your notes that it matches up with. All right? Good luck, and we'll see you in class tomorrow.